This is part 245, line 22E5B, ether, hydrogen, atoms, hydrocarbons, hybridized orbitals, Wow Seti. And there's the alien radio signal. The general structure of an ether, quote wiki, ethers are a class of organic compounds that contain an ether group, an oxygen atom connected to two acyl or aryl groups of general formula ROR. That's where that... Sorry, I stuck the graph on another video, just realized it. Okay, a typical example is the solvent in anesthetic diethyl ether, commonly referred to simply as ether. C3CH2O CH2CH3. Ethers are common in organic chemistry and pervasive in biochemistry, as they are common linkages in carbohydrates and ligand. Now we had ligand come up earlier in the last few videos. Ethers feature COC linkage defined by a bond angle of about 104.5 degrees and CO distances of about 140 pm. The barrier to rotation, again we're talking about rotation, so this has something to do with the UFO body, like the outer shell or the inner core. The barrier to rotation about the CO bonds is low. The bonding of oxygen in ethers, alcohols, and water is similar. In the language of valence bond theory, the hybridization at oxygen is sp3. Oxygen is more electronegative than carbon. Thus, the hydrogens alpha to ethers are more acidic than in simple hydrocarbons. They are far less acidic than hydrogens alpha to carbonyl groups, such as ketones or aldehydes. However, depending on the group of R and R, ether is classified into two types: simple ethers or symmetrical ethers, mixed ethers or asymmetrical ethers. In chemistry, valence bond VB theory is one. Here we get another theory here. Is one of the two basic theories, along with molecular orbital MO theory, that were developed to use the methods of quantum mechanics to explain chemical bonding. It focuses on how the atomic orbitals of the dissociated atoms combine to give individual chemical bonds when a molecule is formed. In contrast, molecular orbital theory has orbitals that cover the whole molecule. 4 sp3 orbitals, 3 sp2 orbitals. June 11th, 2012, my thoughts. I see this orbital thing and I think UFO spaceship rotational properties to make it go around the sphere that's inside of it. Quote from Wiki. Orbital hybridization. In chemistry, hybridization or hybridization is the concept of mixing atomic orbitals to form new hybrid orbitals. Hybrid, that's kind of like solar power, air power, water power, that type of thing. Wind power, suitable for the qualitative description of atomic bonding properties. Well, that's just what I think of when I think of hybrid. Okay, hybridized orbitals are very useful in the explanation of the shape of molecular orbitals for molecules. It is an integral part of valence bond theory. Although sometimes taught together with the valence shell electronic pair repulsion, VSEPR theory, valence bond and hybridization are in fact not related to the VSEPR model. The hybrids are named based on the atomic orbitals that are involved in the hybridization, and the geometries of the hybrids are also reflective of those of the atomic orbital contributors. For example, in the methane CH4, a set of sp3 orbitals are formed by mixing 1s and 3p orbitals on the carbon atom, and are directed towards the 4 hydrogen atoms, which are located at the vertices of a regular tetrahedron. June 11, 2012. See the keywords in this: orbital hybridization, atomic molecular molecules bond theory, methane are all mentioned in lines 22A to E. Now I have to Google the odd one out, tetrahedron. So we'll try to go to the next video, but we got low power here.